Hello and welcome back to Grasshopper Introduction course for the University of Queensland. It's Christina here with you today. Now when we're clear with primitives and curves, let's have a quick look at another panel in Grasshopper called Math. Here it is. Well, why would you need that? Because you're describing your geometry with numbers, so you'll need it quite a lot. And now let's see how it works. Let's try subtraction, and it requires us to put numbers like a calculator, quite easy. Let's call a slider, and what would I like to do? Let's say 50, and another slider, let's say 60, and I want my result to be negative, so I will be subtracting 60 from 50. Then to see a result, we need to call a panel. This one is called panel. It's located here in params input and can be dropped like that, and it contains information received from the previous node. It doesn't do anything, it just has information. But next, let's try multiplication. We'll get to all the rest of this operations later, but now let's just do math. We're multiplying a, which is minus 10, on maybe 5. And let's see what we have. You can call this panel also by double click and double slash, and it appears. That's right. Minus 50. It works. What's next? Let's try division. Division. And divide minus 50, 25. Double slash. Here we go. And that's right. And later you'll see how you can use math in your design. Now, quite often integers and numbers from params are used in some operations, and they basically hold numerical value. I'm talking about these guys here. They hold a numerical value respectively. So let's say we have a panel. This panel cannot just show you the result, it can actually contain information. So let's set multi-line data so it sees our numbers in sequence, and let's multi-line, and let's put some numbers here. Let's put 0, 5, then I don't know, it will be random, something with numbers, something with values after point and without, just so you can compare. Okay, done. So it's multi-line data, and you see how it's stored in different lines. Now let's have integer, which contains a collection of integer numbers. Connect our panel to that, and to see outcome we need panel again. What do we see here? 0, 5 is rounded and it's 0, 20 stays 20, 177 rounded, now it's 2 rounded. If we had here, let's say 4, now it's 5, 18 stays 18, and 147 is rounded to 1. If we had here 157, for example, here it is 2. That's what integer numbers do. They contain integers, and if they receive information as non-integer, it transforms this to integer. Next thing I want to try out here is Boolean. Those of you who worked with Rhino know how you might use Boolean operations. And it's pretty much the same here in Grasshopper, it's just going to be node-based. So first of all, let's draw 3 closed curves in Rhino, and let's make them all intersected so that we will see how Boolean works in this exercise. Okay, here we go. Now we will need to assign the geometry, and here we go to params and to curve, because we are taking the geometry from rhinoceros. That's when we use params. Okay, Ctrl+C, Ctrl+V, because we need 3 of them, and let's set them. Set one curve, this one, perfect, set one curve, next curve, and we're doing, sorry, be careful when you click in, you might click something you don't want to use. Set one curve, it's this one. Now let's go to Grasshopper Intersect, and here we have Boolean Operations. Let's call them all in turns. So this is region difference, region union, and region intersection. Let's do it actually like that. It's orange because it requires data from here. So we have our curves, 1 curve, 2, 3. Region difference. It's curve to subtract from, curve to subtract with. And what do we see? Basically nothing. Why? Because we need to call a component to see the result. So let's go to surface, and let's have this boundary surface and connect it, and here we go. We have subtracted from this shape by this shape this small bit. Quite easy and understandable. We'll need this component again. Let's try region intersection. Let's try to take curve 2, curve 3. You don't really need to specify a plane, it's optional. And let's see. Here we go, here it is. If we don't want to see this bit, because we don't want to look at it, we're hiding it. Here we have 2 curves, curve 3 and curve 2, and here their intersection. Pretty much the same as we would have done it, and as we would have it in Rhino if we did it just faster here. Now this one is slightly different. As you can see, it's region union, and it doesn't have A and B ports. It has curves, various curves. So we take this curve and this curve, and you see it doesn't allow us at first to put them together here, but it will if we just press shift and put them together. And then what's the result? I don't want to see that, it's confusing. Region union, union of 2 closed curves. We can actually disconnect by pressing Ctrl and going the whole way back and connect it to this one, also with shift, and this one. Sorry, I was pressing Ctrl. Here we go. Or we can add this one. So now you know how region intersection works, and region union and all other regions. So see you for the next exercise with the parametric vase at the Grasshopper course at the University of Queensland.